So this is section 14 on properties. I'm more interested this time actually on properties than actually solving for the appropriate variable. Now the reason I chose this specific example, this is going to fall more into literal equations later, because we have two variables, is the fact that I'm solving for x, but notice x appears twice. Now we did this in the previous sections when we had like 3x and then like 2x or something, but certainly not when we have an extra letter here. So really what I'm focused on this time really is, what am I doing for my properties? So what I'm looking for is what's changed here. So I notice on this first step, if I look above, there's an extra 2y being added to both sides. So that's an example of my addition equality, for example. So that's what the lines here are actually saying. What have we actually done to get from one line to this next line? So for this next one, how did I get from here to here? Well, I got a negative 2y and a positive 2y, so these are inverses of each other, which gives me 0. So that would be my example of additive inverse, because I've got one that's positive here. Don't say negative inverse, we always say additive inverse if there's one positive and one negative. And on the next step here, well, I've got 3x plus 0, but the next step I got 3x. So I started with 3x and I finished with 3x, so nothing changed. So that's an example of the identity property. And as I was adding something, I'm going to put additive identity. Now on the next line, you can see that there's been additional terms here. So on both sides they're subtracted by x and z, or x and z. So that would be an example of equality, just like I saw before. Oops. And as I was subtracting, equality of subtraction. So on the next line, let's see what I actually did. Oops. So I had x and z and negative x and z, so there's the inverses of each other, so I got 0, so I can say straight away for that that's going to be inverses. And as one was positive, I can say additive inverse. On the next line it went from 0 plus 2y to 2y. So I started with 2y, finished with 2y, nothing changed, so that would be an example of, oops, an identity again, and as it was to do with addition, that would be my additive identity. And then the next step, perhaps not quite so obvious, I went from here to here. Now actually if I said go from here to here, this might be an example of distributive. X times 3 is 3x, x times z is xz. So it's actually my distributive rule in reverse, but that's still the distributive rule. Actually that's factoring, and that's something that we'll do in another topic, when you do the opposite of the distributive rule. And then I was trying to solve for x, so if I divide both sides by 3 minus z, these would cancel and I'd just get left with x. But I've got to do it on both sides, so that would be an example of, oops, I'm missing a step here. That would actually be an example of equality, because I did the same on both sides. So equality of division. And then how I cancelled this out, one was times and one was divide, that's why I put multiplicative inverse. So the same sort of ideas. Now if we go back and actually look at what we actually did here, when we try and solve for x, what we try and do is bring all the letters to one side, which is what I tried to do with my x's here. I tried to bring everything to one side, but anything that wasn't an x, I tried to move across to the other side. So once I've got all my x's on one side and then numbers on the other side, I just had to find a way. Normally I would just subtract these. I would say, what is 3x take away 2x? Now I can't do that with this one because I got 3 take away z, so I just put 3 take away z times x. And then our last step, when we're multiplying, we always do a division question. So at the moment, just make sure you understand all those properties, and we'll come back to more questions like this when we do literal equations later.